don't freak out. So I just want to start with a quick acknowledgement. This project was done over Eastern North America, and as much as I love epic road trips, it was really efficient to have people collect samples for me and mail them to me. So that's what all these people did, and I also got to go with Christina's group to get samples from caves in Ontario. So I'm talking all about pseudogenesis destructans, which I'm assuming all of you are somewhat familiar with because it causes white nose syndrome. Fungus that causes white nose syndrome. Started in New York in 2006, spread from there all around North America, and it persists in caves and mines, hibernacula, without bats. You do this for years. In the literature, up to 7 years in caves from when it's first introduced into an individual site. And this is a problem because even if bats are extirpated from the caves, and new bats come in, they can get reinfected, pick up fungus from the cave environments and potentially get sick all over again. Not awesome. There's a lot of projects out there looking at how to clean caves and mines, get rid of the fungus from these sites. Lots of different chemicals, UV light, there's a lot out there that people have suggested. But it's been almost 20 years since it first started in New York when we first detected it. Does it really stay that long? This is my question. Is it still there? Here's your back pictures. So back in the day, I took the picture on the left there, that's in New Brunswick, when it was first introduced there. We see bats with white noses all the time. Really luxuriant fungal growth, especially in April, is very common. When I did all my swabbing studies back in the day, like 100% of the bats had fungus. It was everywhere. I could easily detect it off the walls, off of insects, not hard to get rid of. It's a little bit different these days. I know some of you have gone into caves. You don't see the really white noses anymore. Like in 2024, this was the worst bat I saw. You can see some white patches on the wings there, but the nose is totally fine. Like, we're not seeing this really luxuriant fungal growth anymore. But it's just visual. Like, a bat can have fungus without visible growth. We're not ready to see microbes, so what's actually going on here? Back in 2012, when I was working in New Brunswick a lot, I did a swabbing study of the walls. It depends which agar type you use, I'm not going to go into that, but about 40% of my swabs of cave walls had fungus. Pretty high, not as high as the bats. But then when I replicated the study a couple of years later, it had gone down, not statistically significant, but then I replicated it again in 2022, and way down, really down. Especially with my culture dependence and growing in their petri dishes, it was less than 2% of my swabs were positive. And I really increased my sample size. That's 120 swabs. I guess that was 3 years ago. Time flies. My qPCR results were a bit higher, so this also detects dead DNA, but it's still quite low. So I think that was around 12% or something like that. Certainly not what we used to see in the literature when people were doing this 15 years ago, or whatever it was. We also were wondering what's going on with bats. So Hugh Brothers agreed to help me out, took some swabs in Nova Scotia, swabs of bats, and the little browns were still like 80% of them had the fungus still, but over the winter, so going from November to April, it actually decreased. So that's the opposite pattern of what we used to see. Really weird. But my sample sizes were quite low for Nova Scotia and bats in general. So my current project was to try to really increase those sample sizes and also get out of the Maritimes a little bit. I love the Maritimes, I want to do more work there, but the bats, populations there, especially the caves, aren't that big. They weren't to begin with, even the great white nose, and now they're really small. So I wanted to get farther south where there are still larger bat colonies to see if it's the same story. Yeah, that. So experience sampling last winter and this winter. I have data in hand from 12 states and provinces. I have samples in hand from Quebec and Maryland, but I haven't processed them yet. And I'm expecting samples from Virginia and Connecticut in the next few weeks, so we'll see how that goes. But right now we're looking at data from 49 sites, and that's what I'll be presenting. So these are up to 18 years post-PD, and post-PD is just individual sites. I didn't sample any sites that weren't previously positive for the fungus. So I know that we used to be in all of these sites, and approximately at least what year that happened, at least when we first detected it. So we had people take swabs from close to bats where you would expect higher fungal loads and prevalence, and also far from bats in these sites, but still in areas of the caves where the bats are living. So in terms of the number of bats in these sites, most of them are less than 5,000, that's not surprising, but I did have some quite large sites, over 20,000 bats, and I have this sort of same data presented a little differently with the different scales, so you can see more detail of what's going on there. So we did have a huge site with 500,000 bats. These are mostly gray bats. But even in New York, we still have sites with 20 to 27,000 little brown bats, which is great. We don't have that in Canada, but oh well. At least there's still in New York. But most of my sites, you know, it didn't have huge bat colonies usually. Like most of them were less than 200 bats. So this is most of what I found. So the black dots, that's all from the literature. You can go look that up yourself. Whoa, that's a weird color. Sort of mustard, I guess, is data from my study. This is all wall swabs, so no bat data here. And it's really decreased over time as we're getting away from when it was first introduced into all these different sites, which is great. So this data is with using a CT value cutoff 40. This is sort of a discussion of what CT value to cut off here. It's an inverse relationship. So the higher the CT value, the lower the load, the fungal load, which is weird, but anyway. The CT value cutoff is 40. It's often used in White Nose literature. It's not used by governments. So for Canada, they usually use a cutoff of 35. In the US, 37. But I'm usually going to present at 40 because that's what most of the scientists do, that's what we used to. So this is just presence of fungus, not load. So I have increased my bat samples, still about half of the bats still have fungus. But you can see the walls are really low these days, especially far from bats, so 4% of my swabs are positive. For close to bats, it's higher, it's not a surprise, since the fungus is growing on the bats, or only 15% of those were positive. Lowering the CT cutoff to 37 certainly changes the results. So less than 1% at this point are positive for the far swabs, and then 6% for the near. So this really tells you that even my positive hits really low fungal loads. I'm not getting heavy fungal loads on any of these swabs. Still for the bats, these are close to 40%. I say bat here, but it is actually multiple species. Most of my swabs are from little brown bats or tricoated bats. There's a few big browns in there, but I was really trying to target the really susceptible bats, the ones that have suffered the biggest mortality. I did separate it out by species here, but you can see the trend. So prevalence on the walls. If you're in a site and you see visible fungal growth on a bat, you're far more likely to get a positive hit on the walls in the site. Not a huge surprise there, but it's quite dramatic in the statistics. So moving on to load. So the loads are very low. There were visible fungal growth on bats in only 31% of our sites, so quite low. It used to be basically all of them, so that's great. And you can see that even seeing the visible fungus on bats really changes the load as well. So comparing the nose in the green to the black yeses. And because I have a few outliers out there, those are in New York and New Brunswick, I just changed the scale here and got rid of those so you can see a little better the pattern with the no guess visible fungus. So this is especially clear on the bats. If the bat has visible fungal growth, the wall near the bat is more likely to have the fungus come out positive. So that's not a huge surprise. And also to have it have more of the fungus, not just binary yes no. So this is cool. It looks like the fungus is kind of disappearing from Eastern North America to some extent, or at least way down from what it used to be, which is great. I think we want to think very carefully about management actions to spray bleach in caves to try to get rid of the fungus since it's already kind of going away. But it's really interesting to me in particular because I love cave ecology. but it is still present in some sites and not others. The vast majority of my sites are zero, nothing. So why is it in some sites and not others? And even within an individual site, it varies from year to year. There was only a few sites that I sampled more than 1 year, mostly in Ontario and Brunswick, because I physically do this myself. But it does change. Why does it change? What are the drivers of all of this? These are some of the questions I'm really interested in the future, and what cave characteristics drive these things. It certainly, from my statistical analysis, it certainly doesn't seem to be colony size. You think it'd be intuitive, right? More bats, more fungus. That's not what I'm seeing these days, which is nice, actually, because we're hoping that the bat population is going to come back, right? So that carries the logical risk that, oh, well, maybe when the bats come back, the fungus will come back. But that's not what we're seeing. Because like in New York and in the United States, we still have sizable bat colonies, and they're not any more contaminated with fungus than the small ones. So, yay! Anyway, we're on a high note. So thank you again to all of my collaborators and my funders.
Thank you so much, Karen. Unfortunately, we don't have time for questions, but that was really nice to have a good news story for a change.